Hello, everyone. Welcome to the last ArchSoc talk of the year. We are lucky to have Andrew Kandel with us this evening. And as you know, many of you tried to attend the Tuesday, I think it was the second Tuesday of November talk, and he was unfortunately ill. And he has definitely recovered quite a bit since then, but still has a bit of a gravelly voice this evening. So he's going to make his way through the freezing cold winter in Germany and get through this for us. So that's very kind of you to reschedule and give us your talk this evening, Andrew. And so Andrew, many of you know Andrew. He's been based in Cape Town for many years before we moved over to Germany. And he's got research projects in a number of places. And this evening's talk is about a site in Israel, and he'll be covering the Pleistocene occupation of this site and all the latest work that has been found at the site. Andrew works at Tübingen University in Germany, and he's been working at Sefunim Cave, which is one of the largest caves in the Mount Carmel, and shows evidence of repeated use dating to the Middle Paleolithic, Upper Paleolithic, and Epi-Paleolithic periods, as well as Neolithic and historical time. So it's quite a dense multi-component site. He's going to look at some of the latest results, including studies of radiometric dating, archaeogenetics, fauna, and even the sediment itself. The cave yielded the largest collection of Stone Age shell beads yet documented in Israel and sheds light on the symbolic life of its early inhabitants. The new results provide a more complete picture of how Paleolithic people made use of the cave and the resources surrounding it. So I'm very much looking forward to this talk, and the questions, as usual, will be at the end. We're completely live this evening, so there's no pre-recorded session in this evening. So hopefully the internet plays ball with us and we don't have any interruptions. And hopefully it's smooth and we'll see how it goes. So Andrew, over to you. You can take it away.
Great. Thanks for that nice introduction, Nick, and good evening, everyone. I'm happy to be joining you from Tübingen, Germany. I'd much rather be in Cape Town than in Germany right now. It's snowy, cold, and windy today. And certainly it makes me think fondly on the times we spent in the field in South Africa, taking the ArchSoc on various excursions and joining the talks live. But I think this is a really nice opportunity for me to also come in from far away and to tell you about some of the work I've been doing in Israel over the past decade now at a site called Sefunim Cave. And just to give you an idea of how I'm going to tell you what I want to tell you, the first part of the talk is going to be about background and an overview of Paleolithic archaeology in the Levant. I think you need to understand a little bit about the hominins present and about the cultures that are present in order to be able to fully understand some of the work that I've been doing at Sefunim. And then in the second part of the talk, I'll tell you some of the details. And of course, given that I'm going to talk for around 45 minutes at the most, it will have to be brief. But during the question period, if I've left something out or if I didn't explain anything clearly enough, feel free to ask me about it. So the big question, or one of the big research questions in the Levant, is Neanderthal or modern humans? And they're two of the main actors in the region. And we get information about these from not only the human fossils, but also the cultural remains, the archaeological finds that we excavate at different sites. And in the future, although not right now, genetic material will come to play a bigger role, but for now I'm going to mostly gloss over that. So what does it look like in the Levant? Well, we have Neanderthals who were around for a long period of time during what we call the Middle Paleolithic. That's sort of akin to the Middle Stone Age in southern Africa. And at some point, they're replaced by modern humans. And if we look at the distribution of sites where we actually have Neanderthal fossil remains, you can see there's really just two hands full. And they're mostly centered in the southern Levant. That's basically the coast of Israel and Lebanon. And there's a few outliers, but sort of the central area, you could say, is basically in Israel. The dates that we have for those sites, and many of them are undated still, but the secure dates we have place us in two time ranges, sort of 130 to 100,000 at Tabun Cave and between 70 and 50,000 at Amud Cave. So that's the one side of the coin. The other side of the coin is, where do we have modern humans? And you can see from some of these examples, we've got a wide range of dates. So this presents us with a lot of questions. Why do we basically have alternating or concurrent occupation by Neanderthals and modern humans in the Levant? And in the past couple of years, actually, two important sites, the two M's, Monot Cave at around 60 to 50,000, as well as Mislia at about 180,000, have really opened up our eyes to the presence of modern humans being around for much longer than we expected. And strangely enough, this is being mirrored in other sites. For example, in Morocco, you might have heard about a site there called Jebel Irhoud, where we have modern-looking fossil remains from around 300,000, and also in Greece at a site called Apidima, where we have modern-looking remains around 200,000. So these new findings of the last decade, in addition to ones we've known about for a long time from school in Kafsa, are really complicating the question of what happened in the Levant and how did the transition look from Neanderthal to modern human. And so now you might ask yourselves, after we looked at the human remains, well, what do the cultural remains look like? That was the second aspect I said I was going to focus on. So when we look at the distribution of Middle Paleolithic finds, who we often call Mousterians, we see a special kind of technology, one you're probably familiar from the MSA of Southern Africa, and it's called Levallois technology. And you can see here in the slide that there's a lot of pointed objects, there's some elongated objects, but these forms were created during doing a specific kind of technique, which we call Levallois. So that's how we identify this Middle Paleolithic occupation. And up until very recently, we associated this with Neanderthals in the Levant. But as you can guess from the slides I just showed you about where Neanderthals and modern humans were and when, this is no longer valid. And so now we have a very difficult time telling the difference. The one thing we can say is when we change from the Middle to the Upper Paleolithic, which is sort of similar to the transition to the later Stone Age in southern Africa, we do see changes in technology and typology of the stone tools. We see different types of artifacts coming into play, especially organic tools like bone and antler points, shell beads, and many other aspects. And you can see by the dates here that we have the very first phase of the Upper Paleolithic, which we call the initial Upper Paleolithic, starts around 48,000, and we see traces of it throughout the Levant up until around 42,000. So these are the big points that I wanted to make in the beginning to give you a framework that you can understand some of the questions we're going to ask. And obviously the big question is, who made the Mousterian tools? And also really, who made the Upper Paleolithic tools? And the first question is much harder to answer. And in fact, we just can't be sure at all who made the Mousterian tools anymore. It could be modern humans, it could be Neanderthals. However, for the Upper Paleolithic tools, it's almost certainly modern humans who are responsible for their manufacture. In addition, to make things a little bit more complicated, the Upper Paleolithic has different aspects of cultures, three phases that we can describe as the initial Upper Paleolithic, the Achmarian, which we also call the early Upper Paleolithic, and the Levantine Aurignacian. And if you're familiar with European archaeology, you might recognize the name Aurignacian. It's a term that pops up around 40,000 and is usually associated with the first modern humans who came into Europe. However, in the Levant, it's actually much later, and it happens after the whole sequence of the initial and the early Upper Paleolithic. And these three entities are rather poorly defined, but in general, we can say that the initial Upper Paleolithic is present pretty much again throughout the region, and it's characterized by a funny mix of Middle Paleolithic technology combined with Upper Paleolithic technology. And the idea here is that it's sort of a transition from the previous to what came after. And you can see by the stone artifacts that are depicted here, some of them are reminiscent of those points and elongated pieces that I showed you from the Mousterian, but other ones are typical scrapers we'd see from the Upper Paleolithic. After that comes the early Achmarian, or early Upper Paleolithic. And again, this is distributed throughout the Levant. And here we see a move towards very clear Upper Paleolithic technology. We have lots of blades. We start to have bladelets. We have different kinds of cores using different kinds of techniques to create these artifacts. And finally, the last of these three phases is the Levantine Aurignacian. And for me, that's the most intriguing, especially because Sefunim is a really good example of a classic Levantine Aurignacian site. And here we see all of these attributes that we've been talking about, this bladiness, the bladelets, we see bone tools, we see tooth ornaments, shell ornaments, we see the use of ochre, all these things that probably coming from your perspective in South Africa, you might say are related to the Middle Stone Age. But here they're really, really benchmarks, hallmarks of the Aurignacian. So how can we characterize the Levantine Aurignacian? There are certain types of tools and certain types of techniques that we see repeatedly. And while they're not just isolated to this third of the three time phases I spoke about, they're really most pronounced in this phase. And you can see the list on the left side. We have thick and steep scrapers. There's nosed and shouldered scrapers. I think you can see my mouse, hopefully, so I'm going to try to go over the pieces here. There's multifaceted burins, like this one here, which we often called carinated. We see bone and antler tools, like those that are depicted here. There's these little Dufour bladelets, which are made using a special technique. And finally, there's these things called Elwad points. And some of the technology we see is characterized by Aurignacian retouch. It's a very coarse retouch that you see here on this piece that has the arc on it. We also see thick blade planks. It's a flake-dominated industry in general, although we do have blades and bladelets. And that idea of carination, these two pieces here are great examples in the lower left corner of carinated cores. And sometimes the cores, we call them burins, like the one piece I showed you up here, and some of them are even carinated scrapers, but it's a technique that's very common in the Levantine Aurignacian. So to summarize the cultural sequence and give you the full picture, we have the Middle Paleolithic, characterized by the Mousterian, that's starting around 250,000 in the Levant, and it continues till around 40 or 45,000. And these Mousterian people are replaced by Upper Paleolithic cultures. And I already spoke about the first three. The last one also seems pretty logical. It's called the late Upper Paleolithic, and it's the last phase of that which we see. And it's followed by the Epi-Paleolithic, which is basically a microlithic industry. So people focus really heavily on standardized pieces, on backed and triangles and trapezes and geometric forms that you can see reflected in some of these names like the geometric Kabaran. And I've given you approximate age ranges just so you get an idea of how these all fit together. And that pretty much summarizes what I can tell you about the sequence of Neanderthals transitioning to modern humans in the Levant. There's two key sites I'm going to briefly introduce to you. One is called Manoat Cave. You might recall I showed you a skull from that site dated to around 55,000. In addition, there's really beautiful sequences of two of those cultures, the Achmarian and the Levantine Aurignacian, in that same time range between around 45 and 35,000. And the same goes for the very difficult to read site of Uchazla in Turkey, which is also up the Mediterranean coast, where we see other elements of the Upper Paleolithic repertoire. And just to give you an idea of what these sites look like, here's the inside of Manoat Cave. It's very deep, and it became very famous because of this modern-looking skull that was found, I think around 10 years ago, and that was first published around 8 years ago, dated to around 55,000. And then in various parts of the cave, you can see it's pitch dark inside, but they've got lights, they've got generators running outside the cave to supply energy. They're doing a very modern and very painstaking excavation of the deposits inside, and they're finding cultural remains from those two periods, the Achmarian and the Levantine Ordination. And exciting there is the predominance of antler points and bone awls, so basically bone tool technologies that are really the hallmark of the Upper Paleolithic. And the other side I wanted to show you is gorgeous. I've unfortunately never been there, but it's on the very southern coast of Turkey as it becomes Syria. It's just a few kilometers from the Syrian border. And here at this little coastal cave, there's an incredible sequence of initial Upper Paleolithic and Achmarian as well, with slightly different dating. It's a beautiful setting. You can imagine what that must have been like for the people living there. And as well as Monot Cave, we also have examples of bone awls, and here a large collection of shell beads. So we can see some of these other kinds of behavior that start to infiltrate during the Upper Paleolithic. So that ends the first part of my talk, and I hope I've given you at least some insight into the background and the research history and what's going on in the coastal region especially, but also the inland region of the Levant. And now I'm going to move to the site that I've been working on, Sefunim Cave and the Mount Carmel. It's located in the north of Israel, just south of Haifa in the coastal mountain range, which we call the Mount Carmel. It's, of course, a Mediterranean climate, so it's characterized by cool winters and warm, dry summers. Cool, moist winters, actually, and warm to hot, dry summers. The Mount Carmel has an incredibly long research history. It's known, caves have been known there for over 100 years. People have been excavating since the 20s. You might have heard of the Mount Carmel caves excavated by Dorothy Garrett in the 20s and 30s, and many other people followed in her footsteps. In addition, there's very comprehensive surveys, and actively right now there's many Paleolithic excavations going on as well. So it's a really important place in the history of humans in the Levant, and I was lucky enough to get introduced to somebody at the University of Haifa by the name of Ronnie Schimmelmitz, and he and I decided to look at some different sites in the Mount Carmel and think of where would be a good place for us to do some further work. And we met with the original excavator of the site. His name is Avram Ronen. He published a monograph in 1984 about the excavations he conducted during the 60s. And of interest at the site was the fact that he had a pretty complete sequence going back 13 layers all the way to the Mousterian, with some of the elements that I described to you earlier, like the initial Upper Paleolithic and the Levantine Ordination. In addition, a large part of the cave was covered with younger deposits of the Epi-Paleolithic, that's the Natufian, the Neolithic, and also even historical periods. This is a view outside of the cave. I think Nick mentioned it's a very large cave, about 50 meters deep. There's bats inside. There's several chambers deep inside the cave. There's constant dripping water all year, so it would be a really favorable place to be. It also faces to the north, so it's rather equable in its climate. It's not getting the full sun, and it stays relatively cool. During the 60s, Ronen excavated a very large area of the cave closer to the entrance that you see here in gray. But most of that, again, was the younger periods. And the only place that he found Upper and Middle Paleolithic deposits was pretty much near the entrance to the cave, and most of it was covered by large rock falls. You can see some of those rocks there. There's the one that says 767 and the other one that says 1071. Those are the elevations locally of the height of those rocks inside the cave. And so Ron Schimmelmitz and I decided to begin our excavations in 2013 and examine the areas that Ronan had left untouched. And one of our or some of our research goals you can see here. We wanted to study subsistence, so basically hunting strategies and how people use the landscape. One thing to note is we're in the mountains, but the mountains are only about 500 meters high, and we're in view of the sea, which is only 2 kilometers away. So there's a coastal plain that offers different kinds of resources than the rugged limestone terrain of the Carmel Mountains. Since we have a long sequence, we wanted to look at changes over time, of course, to look at how people behaved, to look at the cultural changes as well as changes in subsistence. Important always in modern studies is to know how did the site get to be the way it is, what happened and what changed over time. And we wanted to get some dating because the site until this point was undated by Ronan only back to around 12,000, which was based mostly on the Natufian and mostly based on the types of artifacts that helped to define that culture. So we didn't know how old the other deposits were. So with these goals in mind, we set out to excavate every year in 2013 to 15, plus 17 as well. And you can see here the progress of the excavation. You can see us in between some very large boulders. There's the one really big one at the top of the picture here. There's another very large one right behind me. This is in the year 2015. You can see it's pretty cramped, and that's because we had no efficient way to get rid of some of these larger blocks. Fortunately, in 2017, we invested in some demolition and we got a team of experts to use dry explosives to break apart those huge boulders and to open up our excavation area, which helped us immeasurably, as you can imagine. So here you can see as we were working on in 2017, after most of the rocks that were in our way had been removed. The excavation was actually very comfortable. We were right at the entrance of the cave, so we had enough light, but it still stayed cool most of the time. You might have noticed in the last slide we had a net over the cave. That was mostly to keep the blinding sun off of us because the contrast between the light and the dark was quite irritating. And this is one of the profiles we exposed, being sampled by the geoarchaeologist on the site, David Friesen, who's now working at Haifa, but at the time was at Cambridge. And we divided the stratigraphy of the site into 7 layers. You see 6 of them here. We tried to correlate them with the old layers of Ronan, which we did successfully. And here he's taking block samples. You might know these as micromorphology samples. They make thin sections of them. And then David Friesen here studied those to see how the microscopic processes of soil formation affected the archaeological deposits so we could understand the full history of the site. And when you look at the profile in drawing, you can see here the blue squares represent all the block samples that he took to help understand the transitions between the layers as well as the nature of the layers themselves. And you can also see some of the dating samples, the OSL numbers that you see in purple circles that helped us to date the site better. So that leads us to the next question: how old are the layers? So we use 2 methods, carbon-14 for some of the samples and OSL dating for the sediment. And we tried to date the main occupation layers that you see here. Layer 7 was the Mousterian one. Layer 6 is the initial Upper Paleolithic. Should be a question mark because it's not really sure. Layer 5 is very clearly Levantine Aurignacian. And layers 4 and 3 are late Upper Paleolithic and possibly even the beginning of the Epi-Paleolithic as well. So the deepest layer, the Mousterian layer, turned out to be 70,000 to 50,000 years old. So that would correspond to layers 6 and 7. And we used, like I said, OSL dating. You can see here Nomi Porat of the Geological Survey of Israel and her colleague from the survey taking samples. So that was nice to know that the Mousterian falls about where we would expect it to be. The Levantine Aurignacian, in this diagram, you can see some of the results of the radiocarbon dating of charcoal remnants in the sediments of layer 5. And here you can see they mostly fall between the time period of around 39 to 33,000. If you recall from some of the slides I showed you earlier, this is really consistent with the other sites of the Levantine Ordination in the Levant. So that was a really nice confirmation. One thing I would say is bone preservation is horrible. So we couldn't date any bones because there's no collagen preserved. But some of the charcoal was an adequate shape that we could get good dates off of small pieces that we found in the soil. And finally, the upper layers, layer 3 and 4, dated to 27 to 21,000 using OSL. Here you see again Nomi Porat of the Geological Survey. Some of you might actually know her because she's worked with Michael Chazen at Wonderwork Cave and trying to come up with solutions to dating that complicated site in the Northern Cape. So she's actually also working in South Africa, and that really attracted me to working with her because of her experience there. So I think now you have an understanding of what the chronology looks like. There was nothing earth-shattering there. What was interesting was to ascribe the undated layers to specific time periods and that they fit within what we would normally expect. So nothing too exciting to report there other than increase in our knowledge. So what did the layers look like in the field, and what are the main differences between the layers? Here I'm going to focus mainly on layer 5 and layer 3. The reason for that is because they had the most finds. The other layers actually had relatively low levels of find intensity, of low occupation, and so it's harder to come up with ideas about what they looked like. But in this photograph here, you can see layer 5, the Levantine Aurignacian, the one dated to around 39 to 33,000. What you can hopefully see here in the middle is this big blob. It's a shed antler. You can see these large cutting tools here, this large chert object here, and another one over here. And there's tons of debris of antlers. So we're interpreting this area as part of an antler processing workshop. And you recall I talked about antler tools as well as bone tools. And so we believe that these are part of that whole processing of antler. So people collected them, either shed antler or might have also hunted deer to get the raw material to create tools. Another thing characteristic of layer 5 is all of the carinated cores, scrapers, and burins we find. And very exciting, and I'll get into more detail later, is the shell beads that were found in association with this. So this was, for us, a really exciting find. And these are actually some of the first finds that give this kind of detail into this type of behavior. Looking at the layer 3, the late Upper Paleolithic, one thing you can see is there's an incredible darkening of the sediment. It's very clayey. It's much more difficult to dig. And it's basically a lag deposit of bones and stones. You can see just really hundreds of finds scattered across the surface here. These were dated to between 21 and 27,000, you recall. So those are just the main differences. Layer 5, light sediment, silty, quite cemented in some places, versus dark brown and very clay layer 3. So what kind of artifacts do we have, and how do we distinguish the cultural layers? How do we know which one is which? From layers 7 and 6, we don't have so much information because the assemblages are rather small, but what we do see in layer 7 confirms that we have a Mousterian technology, the culture using Levallois technology. In the layer 6, there's very, very few finds, but some of them are reminiscent of this transitional industry, the initial Upper Paleolithic, and other finds at the site that Ronan made were also suggestive of another phase, which I didn't mention, called the Amiran, but that's really a hallmark of this transitional phase that's supposed to be around 45,000. In addition, we have the classic finds of the Levantine Aurignacian. I talked about carinated pieces. There's special kinds of scrapers and burins as well that are carinated, as these examples show you in the upper left. And we have that flat Aurignacian retouch on many of the pieces that go around the edges, which is very typical of this time period. So that was for us sort of a no-brainer. We were pretty sure we knew where we were based on the culture. And finally, in the upper layers 3 and 4, you can see again what I described to you as potentially a hallmark of the Epi-Paleolithic, we see this microlithization. Everything's getting smaller, more standardized. There's all sorts of geometric forms that are popping out. And here are just some examples of those. So I hope you see the main differences between the industries based on that. We also were interested in studying the subsistence patterns, so we studied the fauna. I'm working with Jamie Clark, who's now at George Mason University in Washington and was formerly in Alaska at the university there. And she did, in the field, an analysis only based on the teeth. The reason for that was, in the field at least, we had limited time and we needed to get maximum information, and the teeth are the easiest to identify, the quickest, so she was able to work on the teeth during the field seasons. Unfortunately, for various reasons, including COVID, we haven't been back there since 2017, so we haven't been able to further the analysis, but we're hoping to improve that situation next year. And what she found was that gazelle and fallow deer were the most common hunted species during all time periods, and the ratio changed slightly, but not very much over time. And there were always background concentrations of other animals, especially red deer, which I described to you. That was for the antler and for other technologies. There were aurochs, so basically large bison-like animals, as well as goats, equids, wild boars, hartebeest even, which might come as a surprise to you South Africans. It came as a surprise to me that they have such a wide distribution. And of course, the famous rock hyraxes or dassies, they're also present here. In addition, not surprising because it's a large cave with adequate and ample places for denning, we have quite a few carnivores, wide range from lions and wolves and hyenas, also to small foxes. And interesting point is that small game are relatively rare. And there's a hypothesis in the Levant how over time people's population increased and they intensified the use of all resources and started focusing on smaller game, on faster game, on packages that were more difficult to capture. But we don't see that here at all, with the exception of the fact that there's many tortoises that are present throughout the assemblages, and we attribute this to human collection of the tortoises. They're associated with other faunal remains and the artifacts, including the beads, so there's no reason to think that they're associated with the carnivores. And I'll get to an interesting association between the carnivores and humans later on in the talk. So I want to remind you of that point. Again, as I showed you for many other caves, we have organic tools made from bone and antler. You can see here some of the examples. Some are just simple sharpened bones. Other ones are really finely crafted pieces. In the case of the one on the upper right, it's an antler bipoint, which is a very classic signature of the Levantine Aurignacian. I mentioned that I was going to talk about ancient DNA. So what I'm going to tell you as a little bit of background is, until recently, the oldest ancient DNA in the Levant dated to around 14 to 12,000. And one of the main reasons for this is, in general, in warmer climates, preservation of organic materials is poor. I mentioned that there was no collagen preserved in the bones. That's yet another example of the poor preservation of the organic materials. Makes dating hard, and it also makes extracting ancient DNA not impossible, but quite difficult. However, just this year, a new paper came out from a cave site in the Judean desert with an estimated age between around 100,000 and 40,000 years ago that identified preserved DNA from rodents at a non-archaeological cave site in a dry area. And perhaps the dryness of the area had something to do with it. On the other hand, the Judean desert is very hot. So it still was an important find because it signified that it was possible to extract ancient DNA under the right circumstances. And as part of our studies of the fauna and of the site itself, we also studied the sediments of the cave. Now, you may not be aware of this, but you can actually extract ancient DNA from sediments as well. And we worked with Vivian Sloan, who's now at the University of Tel Aviv, and she was able to extract ancient DNA from some of the sediment samples we submitted to her, which was very surprising. So here are some of the results. In 4 of the samples, There were very low levels, but they were still positively identified in layers 7 to 5. So actually the deepest layers had the best preservation, and there was no preservation in the younger layers. And what she did identify was cervids and hyenids. And you might recall that those are also two species that Jamie Clark had identified among the faunal remains. So there's a very nice correlation here between what the ancient DNA tells us and what the faunal remains tell us. And what we noted was the best preservation was under that large rock fall that I told you we removed in 2017. And so we're thinking about ideas now about why that might have enhanced the preservation of ancient DNA. And one idea we have is that it was a protection from the environment so that it wasn't as badly heated by the sun, and so it stayed at a more constant temperature because of the protection of the rock. Also, perhaps the rock stopped rain from flowing through the site, at least right there where the rock was. And in addition, the carbonate from the limestone would have served as a buffer, and so would have not prevented, but at least slowed down the degradation of the ancient DNA. And on the right side here, you just see some of the evidence that we show that shows, first of all, on the upper one, that the green graphs, you see those two peaks on the left and the right. Those show you that the DNA, just like a thread or like a cord, is fraying at the end. And the higher those peaks at the ends of each one are, we call them substitutions, the more likely it is that the DNA is old. Because, of course, we have to be able to rule out that it's not just from an animal that was there 100 years ago or 1,000 years ago. And the reference samples you see below that show you a comparison of those older samples in the middle, our sample basically, and reference samples of younger animals and how they would look without the degradation of those frazzled ends. And for those of you who are DNA nerds, you might be interested to know that the average length was about 42 base pairs. And that's important as well because the smaller the base pairs usually is an indication that the ancient DNA is old. The younger it is, the more it stays together and the longer the SNPs are. So that's some of the evidence that I can provide you. And I'm not an expert in ancient DNA, but we're very excited by this result. We've submitted for publication, and we've done further testing focusing underneath the rock. And in fact, the sampling that we've done so far shows that we have 9 more samples underneath the rock that preserve cervids and hyenids. But you might also ask yourself, what about humans? Up until now, we haven't found any evidence of human DNA, but obviously that would be something we want to look at because that could help us decide if Neanderthals were at the site or modern humans. The shell beads I've been sort of talking about, and here's just a graph showing you the amounts that are present and some of the kinds of shells that are the most common. And 2 things I want you to take home. First of all, the most common shell is the one on the top called Columbella rustica. You can see that it's concentrated in layer 5, the Levantine or Agnatian layer. And in fact, all of the other species also have their peaks in layer 5, and that shows you that that was the main time when people were really using different kinds of shells at the site, although they continued to use them above and below layer 5, the Levantine or Agnatian. We also did a microscopic study of the shell beads that was done by Iris Groman-Jaroslavsky at the University of Haifa, and she looks under a very high-powered microscope to look at traces of wear, of residues, of any damage or modifications to the shells. And you can see here what she saw was rounding and smoothing and polishing, which suggested to her that there was some kind of a vegetable fiber that was intertwined through the holes of the shells that were perforated by people. And there's also chipping scars on the outside showing that the hole was crushed and produced by percussion from the inside. And so it gives us a little idea of how the holes were made and also how people use the shells. So that's a really important contribution to our understanding of how the shell beads were being used. And it seems like the answer is they were being strung into necklaces like you might know from Blombos Cave and other sites in southern Africa. And just compared to the site I showed you on the coast in Turkey with Chazla, you might have noticed we had about 667 shells. At Uchazla, there's 1,000 more than that, so there's way more. And you can see these changing patterns in distribution. You see that in the older layers, the Tritium dominates, and some of you might have noticed that Tritium looks a lot like Nazarius in southern Africa. In fact, it used to be called Nazarius, but based on genetic studies, they decided to separate the Mediterranean species from the Atlantic species, and so now it has a new name, Tritium, but still Gibbosula, just like Nazarius. We see then in the Achmarian layers that there's more prevalence of Columbella. And then finally, in the Epi-Paleolithic, we see an equal distribution of many different kinds of shells, showing different patterns of use over time. And these same patterns that I show you here for Uchazla correspond also to the kinds of changes we see at Sefunim. So that's very exciting in the sense that we see that there's some kind of a regional trend and there's some kind of signature over time that changes in what people actually preferred to use as their jewelry, as their adornment. Excuse me. So as we can see here, so from a little bit more, a few more examples of Columbella, the most common species. You can see also many of them are perforated, but not all of them. That was also an interesting factor. But it tells us about the different kinds of shells that people incorporated into their behavioral repertoire. It suggests that there's larger scale and long-term networks of exchange during the UP, that groups identified themselves specifically and even over distances, because Uchazla is probably around 500 kilometers to the north, and that this exchange may also have facilitated transfer of other types of knowledge. For example, lithic stone making, tool making, use of other materials, other kinds of techniques that might have been useful for Paleolithic people in the Levant. So I'm going to tell you a little bit about how the site formed. It's always important, and we invest a lot of time. So I think it's important that David Friesem, who's in our team, also gets a little bit of airtime. He looked around the cave to look for natural sediment, and he found above the cave what he called terra rossa. It's basically red clay. And mixed with the terra rossa, he also found windblown silt that's coming from the coastal plain. And so he identified these two materials as the main sources of sedimentation in the cave. And after the sediment was deposited, what he noticed in the upper layers, he saw the decalcification of the limestone in the layers. So basically, it was becoming basic. And that suggested to him that there were times of higher humidity and also acidic soil conditions that helped dissolve the limestone. But it wasn't so extreme that it destroyed all the bone or all the shells. So you have to consider that. As we move down the soil profile in layers 4 and 5, we see an increased precipitation of carbonates, and as the cementation increases, it reduces the ability of water to infiltrate further into the site. And we build these cemented layers inside layer, especially layer 5. And it may even be enhanced by some of the ashes from burned materials that accumulated as well. And that's a process that he's looking into, that he's very interested. What chemical and microscopic processes also affected the formation of these layers? And finally, at the lower section, we see less cementation in the deeper layers, and that's due to the fact that the cemented layers in layer 5 just stopped a lot of the water from infiltrating deeper and worked instead to just cement layer 5 harder in some places. So in addition to the formation processes of the site, he also looked at some of the microscopic aspects, which he calls microarchaeology. And what he determined was there's these alternating phases. And in the main occupation horizons in 3, 5, and also to some degree 7, he sees more evidence of fire through, on the microscopic level, burned bones, burned shell, clay that's been rubified or burned, charcoals, he calls them microcharcoals, and even ash. And these are all clearly due to increased intensity of human occupation. Fire is the main signature there. Interestingly enough, alternating with these in layers 4 and 6, he also sees more evidence of phosphatic grains and coprolites. So basically, hyenas making coprolites especially, but also possibly other animals. But the coprolites of hyenas are the best preserved. And that shows us that there's increased intensity of carnivore activity on occasion as well. And in fact, it's not just a black and white story, as you can imagine. Nature doesn't behave very cleanly. Instead, we see phases even within the main occupations where there's more evidence for fire or more evidence for phosphatic grains and coprolites. And so we see this interesting dynamics of humans using the cave, and then when they leave, hyenas are coming and using the cave as a den site. And that makes perfect sense, really, if the humans aren't there. But there may also be mutual respect of the animals and humans. The hyenas may be attracted, for example, by the debris the humans leave behind. There's all sorts of stories you can imagine, and we're working actually on a publication right now that deals with this question exactly. Finally, just to sort of sum up some of the other categories of finds, ochre use, you may be familiar again with Blombos, but many other sites like Klein Klippes in the Southern Cape, where ochre is a major source of pigment. We also see that in the Levantine Aurignacian especially. We see traces of grinding, like in the lower right. We see pieces of a material that could have been easily used as ochre in the lower left. And we even see artifacts that are ochre stained that show the direct contact of chert artifacts in contact with ochre. And there's also some oddities that we've discovered that were rather exciting. These belong to younger periods, but I thought they're worth mentioning because for me at least they were very unusual. First of all, there's a polished obsidian bead. This is much more common from the Neolithic. And we're working on sourcing where the obsidian came from. There is no obsidian in Israel. There's none in Syria. The closest sources are in Turkey or Armenia. So any event, we're talking about very long distance transport of materials, probably on the order of over 1,000 kilometers to get that obsidian bead to Israel. There's also sort of a weird chert nodule that's been shaped and formed and that was colored with ochre. Another example of the use of pigment and potential symbolic behavior. And finally, there's a bladelet, that is adorned with a very clear geometric signature. I hope you can see it in the blue box here, but I've drawn it for you as well so you can understand what the pattern looks like. We're not really sure why that is. It's not completely unknown from this period, but it would be normally associated with the Epi-Paleolithic, so the last phase of the Paleolithic in the Levant. So to conclude, we've got about 1.5 meters of sediment that we sampled in many different ways. We looked at changes over time in the lithics, in the fauna, in the shells, as well as other materials, and especially observed differences in two of the main occupation horizons, layer 5 and layer 3. We confirmed the dates of the Levantine Aurignacian at Sefunim to between 39 and 33,000. We also confirmed the dates of the late Upper Paleolithic to between 27 and 21,000, and that borders perhaps on the earliest part of the Epi-Paleolithic. We also documented the richest collection of shell beads known from Israel so far. I told you about the site of Uchazla, which had 1,700, and there's also another site in Lebanon called Ksar Keel that also has several thousand shells. But in Israel, at least, this is the largest collection we know to date. So where are we going to go in the future? We're hoping to continue our excavations next year if COVID will allow it. And we're going to continue analyzing, of course, all the materials that we've collected. We want to expand the studies to include birds and other small mammals so we can understand more about those. We want to do more environmental studies, especially focusing on the ancient DNA studies, which turned out to be very promising, but also looking at isotopes to tell us more about the environment. We'd like to refine the dating scheme. You can never have enough dates for a site. And the most important is to deepen the excavation so we can get a larger sample of those rather obscure layers that we only have a few pieces from. And in the end, I hope I've shown you that the goal of this project is to look at changes over time, to understand how humans survived and interacted with their environment. And with that, I'd like to bring the talk to a close and thank some of the contributors to the research, especially to the Israeli Antiquities Authority, the Leakey Foundation, as well as Professor Avram Ronen, who made all of this research possible, as well as teams from Tübingen, from Haifa, and from several other universities as well. So I thank you for your attention, and I'm available for any questions you might have.
Right. Wow, that was wonderful. Thank you, Andrew. Yes, that was that was an excellent talk. The images that you had of those deposits, it looked like quite a challenging site. You talk about this cementation. So what was that? What was that like trying to excavate through that? Was it cemented rock solid, or was it cemented that you could just kind of peel away through it relatively easily?
Yeah, that's an important question. In fact, I described how the cementation sort of increased with depth, and that was sort of one of the characteristics of layer 5. At first, it was very easy to dig and was very pleasant, and then there's some places where we have to use a pick to smash it up. And you can imagine the more you use a pick, the more you smash things up, the harder it is to recover the fines. And the fines get covered in carbonate so that they just look like blobs and you can't tell what things are. And you can smash them open to try to look inside, but then you destroy them. Or you cannot smash them open at all and then not know what's inside. So it's the proverbial problem that we have when we deal with such kinds of cemented layers. On the other hand, I can't complain because in Israel, the Middle Paleolithic is noted for its very highly cemented sites. I mean, there's sites where people are using electric drills to dig out these materials. And there's some very exciting new things coming out, which I might give a plug for right now because it's relevant to the discussion as well of Neanderthals and modern humans. But very close by to Sefunim, there's a site called School. And my collaborator, Ronnie Schimmelmitz from Haifa, is also working there. And that was a site of at least 10 burials that were discovered in the 20s and 30s. And due to the different technologies and things, people had a hard time extracting it, but they took them out often in big blocks and then excavated them again with picks and hammers in the lab. And what's very unclear about these sites is, are they Neanderthals or are they modern humans? And most people say they must be modern humans based on their morphology. But now there's several other new sites that are just discovered. One is called Tin Shemet that has exactly the same setting. It's being excavated by Hebrew University with help from Tel Aviv. And they have a very similar setting. And these are all finds that are encapsulated in cement, basically. And they're such important finds as well. You can't believe. So, from that regard, the problems that I just mentioned are trivial compared to what these guys are going through to recover these materials. But they're extremely important, and they're leading us to a whole new understanding of that interplay between Neanderthals and modern humans.
Yeah. No, it's hard to explain to people how much luck goes into the site formation, and you have to work with what you've got, and it's some things could be terrible for one period, as you pointed out, was fortuitous, a sort of capped but then protected layers below that. So it's you just go with it, and the more sites we excavate finely like this, I think it'll kind of create a mosaic. We'll kind of figure it out, but gosh, it is quite working through cement.
Yeah. One thing is there a question? Because otherwise I could just add a quick comment as well, and that is that I simplified the story grossly. I had to, of course, to present it in a coherent way that people could relate to. But the story is even more complicated about Neanderthals and modern humans as well, because there's very good evidence that there was also another archaic-like non-Neanderthal hominid on the landscape. And that's something that a lot of people are dealing with right now, going back into like MES 6, so the time period about 200,000 to 130,000. And they're finding human remains at a site called Nesher Ramla. My colleague Yossi Zeidner is working there. And he's also the one who's working on this cemented site I told you called Tim Shemet. And that really complicates the picture even more, because then it means, like in other places in the world, we don't have just a simple linear story. We don't even have a binary story. We have multiple hominins. They're very hard to identify, and they all seem to make the same kind of cultural materials. So there almost had to be interaction between them. We know genetically Neanderthals and Denisovans interacted in Siberia. We know that Neanderthals and modern humans interacted from several sites. So in a way, this doesn't come as a surprise, and it's completely changing our story of human evolution.
Yeah, it's very, very important. I think the next 10 years, because it sounds like there are many researchers working together collaboratively in Israel, which is very exciting. It's similar to the South African scene in that way. There's nice, tight collaboration, and it seems like the results are being shared quite quickly between the teams.
Yes.
Yeah.
Yeah.
Let's see if we've got any questions. Yes, we've got Tim Maggs. Thanks, Tim. He's asking us about, can you tell us something about the stratigraphy under the big blocks of the rock, those ones that you had to blast away and get out of the way? And he says, surely difficult, I can imagine.
Yes, that's an important question, actually, because the rock, it was one big rock that's about 3.5 meters long, 2.5 meters wide, and about 1.5 meters thick. And it was sitting on top of layer three, it turned out. So on top of the late Upper Paleolithic. And of course, we couldn't get under it because we would have killed ourselves if we started excavating underneath it. And even Ronen, who excavated in the 60s, tried to remove it and couldn't. We used in the beginning sort of a variety of mechanical means. That means sledgehammers and crowbars. Then we got some auto jacks and like boards and levers and tried to like move them slowly apart. We smashed them and it just got worse and worse. We went crazy. We injured ourselves through the smashing and the moving. And finally, after 4 years, I guess, I was able to convince my colleague that we needed to get professionals in there. And we got them to use dry explosives. What they do is they drill holes, fill it with this very potent stuff, and then as the material cools, gels, it expands at an incredible rate, and it cracks open the rocks, and then you can move them by hand or many, many hands, as it were. And once we got that out of there, we finally were able to piece together the stratigraphy in a much better way, to get back to Tim Magg's question. So it was really essential for us because we had two divided digs separated by a rock, and we, even within that 1.5 meters, 2.5 meters of distance, we couldn't link the stratigraphies together. So by removing the rock, it was an exceptionally important point because we were able then to figure out what happened.
Yeah, so definitely worth it. Yeah, sure. Let's see if anyone else. We've got about 30 odd people in the audience this evening. Everyone's very quiet besides Tim. By the way, Aryan Harm, I don't know if you know him, is on talk, and he just said hello, or he's joining from Belleville. And Yvonne is also shouting out, saying hello to you, and
happy to see that.
Enjoying your talk.
I would have a plug to do, if I may, if I can do this properly, because in addition to the work I've been doing at Sefunim, I've also been working in Armenia on another dig, and I'm not going to plug that site. But what I want to say is I've been working in a project in Tübingen that began in 2008 called The Role of Culture in Early Expansions of Humans. And it's funded by the Heidelberg Academy of Sciences, and it's part of sort of the National Academy of Sciences of Germany. And the goal, as the name sounds, is to figure out the role of culture in the early expansions of humans. And we have a database of prehistory. And I know you're a big fan of databases, Nick, and other users in our audience, people in the audience might also be interested in this. So I'm going to just briefly share my screen
Sure.
if I can
yeah.
do it. And
I'll go off into the corner here.
let's see if I don't do it correctly.
Let's see.
What can you see now?
Okay, it's coming up. Whoop. Let me just get it
Can you see
a little
this? Can you
smaller.
see?
Just one
Can you see the
second.
map?
I can see the map and just update the stream. Okay, let's send you backwards a bit there.
Okay.
Okay, let's see if I can get you underneath the map. Yes. All right. So there we go. Okay. Fire away.
Okay, what I want to tell you is we have a database of archaeological sites older than 20,000 years on a global basis. And you can see here just a background map of the world from Google. And the red dots all represent sites that have lithics. So since I know you guys are all interested in South Africa, so you can see here the distribution of sites all over the place, and you can click on them. So there's Paardeberg Cave, for example. I imagine that's Voodoo, not surprising. Can you see the pop-up when it opens?
Yep, yep.
Okay, and so we basically it's an atlas of prehistory, and for each site we have information about where it is and a brief summary of what it is, when it was excavated, what kind of materials the site contains. We also have what we call the geoprofile, which includes dating and all of the layers of the site as we know them, including description of the sediment when it's available. So you can see here a very, very lengthy stratigraphy of Cebudu with the ages of those layers. You can also see the archaeology of the site. Oh, that doesn't look so good. That actually needs improvement. I apologize for that. Bad example. But there should be much more than just the final MSA that needs to be repaired. And then a list of publications that we use to compile the information. And so you can do that anywhere in the world. And if anybody's interested, you can write me at my email. It's pretty easy to find. www.rocky.net is our website, and then you can find my name there and click on the email to write to me. www.rocky.net. Maybe you could send that out as a text message.
Yeah, so
And
www.rocky.
you can use it without a login, or if you're really interested in going deeper, we're happy to give anybody who wants a login identification the chance to work with the database. It's more of a research database, but sort of the aspect that you can get to without logging in is meant for the general public to find out information about sites. And there's sort
I
of
don't think I've got the right URL. Sorry, I was kind of jumping across there. So it's www.rocky.
ROCEEH.
Rocky.net. Perfect. There it is.
And then
Great.
you should be able to find and it's in English. You should be able to find my email when you click down through the thing. I think there's something like personnel or something like that where the people are, and I have a aspect there. Anyway, that was my plug, and I thank you for letting me do that.
Yes, absolutely. Yeah. No, I think the more that everyone's been working on Rocky, and then Saurus and Kenya has got their thing going, and there's aggregation of this data being pushed out, all the time. It's getting better and better and better, and it's very exciting. It's kind of the dream of 20, 30 years ago, finally coming together.
Yeah.
Well, I think we don't have any more questions. I really loved your talk, and I'm sure everyone else enjoyed it this evening. It is the last talk of the year, and I hope everyone has a very happy new year and festive season. It's obviously fourth wave in South Africa, so be safe and look after yourselves, and hopefully everyone gets through this period okay, and we'll resume our talks next year again in February or March. Andrew, you're always such a inspiring and keen archaeologist, and I'm really enjoy your work, and it's such a pleasure always to have you and to interact with you virtually for now. But when you're back in South Africa or when I'm over there, I'll pop in and can say hi. And just thank you for speaking as well. With you're not quite fully well yet, but you came across loud and clear, and it was an excellent talk as always.
Thanks for having me. I really appreciate everybody listening.
Yeah, and have a wonderful evening. Yeah, and look after yourself.
Okay.
Super. Take care.
Bye-bye.